What is Helm, and why is it used in Kubernetes?
Helm is a package manager for Kubernetes that simplifies the deployment and management of applications. It uses charts, which are pre-configured templates of Kubernetes resources, to deploy complex applications with a single command. Helm handles versioning, upgrades, and rollbacks, making it essential for managing Kubernetes applications at scale.
What is a Helm chart?
A Helm chart is a collection of files that describe a related set of Kubernetes resources. It contains a chart YAML file with metadata, a values YAML file with default configuration, and a templates directory with Kubernetes manifest templates. Charts can be shared through repositories and versioned independently.
What is the structure of a Helm chart directory?
A Helm chart directory contains chart YAML for metadata, values YAML for default values, a templates directory for Kubernetes manifest templates, and optionally a charts directory for dependencies. It may also include a helmignore file, a reidme, a license, and a templates/notesdxd for post-install messages. The helper's TPL file in templates holds reusable template definitions.
What is chart YAML, and what fields does it contain?
Chart YAML is the metadata file for a Helm chart containing required fields like API version, name, and version. It also supports optional fields such as description, type indicating whether it is an application or library chart, app version for the application version, and dependencies listing other charts it depends on. The version field follows semantic versioning.
What is values YAML in a Helm chart?
Values YAML is the default configuration file that provides values to the chart templates. These values can be overridden during installation using the set flag or by providing additional values files with the F flag. It serves as a central place to configure replicas, image tags, resource limits, and other parameters without modifying the templates.
How do Helm templates work?
Helm templates use Go template syntax to generate Kubernetes manifest files dynamically. They reference values from values YAML using the dot notation like values image tag and support control structures like if/else and range for loops. Templates are rendered into valid Kubernetes YAML before being applied to the cluster.
What are Helm built-in objects?
Helm provides several built-in objects accessible in templates. Values contains the merged values from values YAML and overrides. Release holds information about the current release like name and namespace. Chart contains the chart YAML metadata. Capabilities provides information about the Kubernetes cluster capabilities and IPI versions.
What is the release object in Helm?
The release object provides metadata about the current Helm release, including release name for the release namespace for the target namespace, releases install or releases upgrade to detect the operation type, and release revision for the revision number. These values are commonly used in templates to generate unique resource names.
What are Helm template functions?
Helm template functions extend the Go template language with additional capabilities. The include function renders a named template and returns the result as a string. The TPL function renders a string as a template. The required function fails rendering if a value is not provided. The default function provides fallback values when a parameter is not set.
How does flow control work in Helm templates?
Helm templates support if/else conditionals to include or exclude blocks of YAML based on values. The range action iterates over lists and maps. The with action sets the scope to a particular object. These flow control structures let you create flexible charts that adapt to different configurations without separate template files.
What is helpers TPL in a Helm chart?
The helpers TPL file is a convention for defining reusable name templates, also called partials, that can be included across multiple template files. Common definitions include chart name, full name, labels, and selector labels. Files starting with an underscore are not rendered as Kubernetes manifests, but are available for use with the include or template functions.
How do you install a Helm chart?
You install a Helm chart using Helm install, followed by a release name and the chart reference. The chart can come from a repository, a local directory, or a packaged archive. You can customize the installation with set for individual values, F for a values file, and namespace to specify the target namespace.
How do you upgrade a Helm release?
You upgrade a Helm release using Helm upgrade, followed by the release name and the chart reference. Helm computes the difference between the current and new configuration, then applies only the necessary changes. The reuse values flag keeps the current values and only applies new overrides, while reset values returns to the chart defaults.
How do you roll back a Helm release?
You roll back a Helm release using Helm rollback, followed by the release name and the target revision number. Helm reinstates the configuration and manifests from the specified revision. You can view the release history with Helm history to identify which revision to roll back to. Each rollback creates a new revision in the history.
What is the difference between Helm install and Helm upgrade install?
Helm install creates a new release and fails if a release with that name already exists. Helm upgrade install, often called upcert, will install the chart if the release does not exist or upgrade it if it does. The upgrade install pattern is commonly used in CI/CD pipelines to handle both initial deployments and subsequent updates idempotently.
What are Helm repositories?
Helm repositories are HTTP servers that host packaged Helm charts with an index file. You add repositories with Helm repo add, update the index with Helm repo update, and search for charts with Helm search repo. Popular public repositories include the Bitnami charts repository. Charts can also be stored in OCI-compatible container registries.
What are OCI registries for Helm charts?
Starting with Helm 3, charts can be stored in OCI-compatible container registries like Docker Hub, GitHub Container Registry, or Amazon ECR. You push charts with Helm push and pull them with Helm pull using an OCI / prefix. This eliminates the need for dedicated chart repository servers and leverages existing container registry infrastructure.
What are Helm hooks?
Helm hooks are special resources annotated to run at specific points during a release lifecycle. Common hooks include pre-install, post-install, pre-upgrade, post-upgrade, pre-delete, and post-delete. Hooks are used for tasks like running database migrations before an upgrade, loading initial data after install, or cleaning up resources before deletion.
How do Helm hook waits and deletion policies work?
Hook waits determine the execution order of multiple hooks at the same lifecycle point, with lower waits executing first. Deletion policies, specified with the hook delete policy annotation, control when hook resources are removed. Options include before hook creation, which deletes the previous hook before running a new one, hook succeeded, which deletes after success, and hook failed, which deletes after failure.
What are Helm chart dependencies?
Chart dependencies allow a chart to include other charts as subcharts, declared in the chart YAML dependencies section. You specify the name, version, and repository of each dependency. Running Helm dependency update downloads the dependencies into the charts directory. Conditions and tags can enable or disable specific dependencies based on values.
What is an umbrella chart?
An umbrella chart is a Helm chart that has no templates of its own, but bundles multiple subcharts as dependencies. It is used to deploy an entire application stack, such as a web server, database, and cache, as a single release. This pattern simplifies managing related services and ensures they are deployed and configured consistently.
What is a library chart in Helm?
A library chart is a Helm chart with type set to library in chart YAML that contains only named templates and helper definitions, no deployable resources. Other charts can include it as a dependency to reuse common template logic like labels, annotations, and resource definitions. Library charts promote consistency across multiple charts in an organization.
What is the difference between Helm 2 and Helm 3?
The most significant change in Helm 3 was the removal of Tiller, the server-side component that had security concerns due to its broad cluster permissions. Helm 3 communicates directly with the Kubernetes IP using the user's kubeconfig credentials. Other changes include three-way strategic merge for upgrades, release information stored as Kubernetes secrets, and improved CRD support.
What was Tiller and why was it removed?
Tiller was the server-side component in Helm 2 that ran inside the Kubernetes cluster and managed releases. It was removed in Helm 3 because it required broad cluster admin permissions, creating a security risk. Without Tiller, Helm 3 uses the caller's Kubernetes credentials directly, providing better security through standard rollback controls.
How does Helm handle Kubernetes secrets and config maps?
Helm can template Kubernetes secrets and config maps just like any other resource. Values can be passed through values YAML or set flags and referenced in templates. For sensitive data, best practices include using external secret management tools like HashiCorp Vault or sealed secrets, rather than storing secrets directly in values files.
What is Helmfile?
Helmfile is a declarative tool for managing multiple Helm releases across environments. It uses a Helmfile YAML file to define releases, repositories, values, and environment-specific overrides. Helmfile supports features like diff before apply, hooks, and templating of the Helm file itself. It is particularly useful for managing complex deployments with many interdependent charts.
How do you test a Helm chart?
Helm provides several testing mechanisms. The Helm template command renders templates locally for inspection. The Helm lint command checks charts for common issues and best practices. Helm test runs test pods defined in the chart's templates/tests directory. The Helm diff plugin shows what would change before applying an upgrade.
What is Helm template?
Helm template renders chart templates locally and outputs the generated Kubernetes manifests to SD-DAUT without communicating with a cluster. It is useful for debugging templates, reviewing generated resources, and integrating with GitOps workflows where rendered manifests are committed to a repository. You can pass values and set flags just like with Helm install.
What is the Helm diff plugin?
The Helm diff plugin shows the differences between the current deployed release and what would be applied by an upgrade. It presents changes in a unified diff format, making it easy to review before committing to an upgrade. This is similar to Terraform Plan and is considered a best practice before running Helm upgrade in production.
How do you pass values to a Helm chart?
You can pass values using the set flag for individual key value pairs, the set file flag for file contents, or the F flag to specify one or more values files. Multiple values files are merged in order, with later files taking precedence. Values set with set take the highest precedence and override everything else.
What is the Helm show command?
Helm show displays information about a chart without installing it. The subcommands include Helm show chart for chart YAML contents, Helm show values for default values, Helm show readme for the chart REIDME, and Helm show all for everything combined. This is useful for inspecting charts from repositories before installing them.
How does Helm handle CRDTKS?
Helm supports custom resource definitions through a special CRDS directory in the chart. CRDTKS placed in this directory are installed before other resources and are never upgraded or deleted to prevent accidental data loss. For more control over CRD lifecycle management, teams often manage CRDTKS separately from the application chart.
What is a Helm release?
A Helm release is a running instance of a chart in a Kubernetes cluster. Each release has a unique name within its namespace and maintains a history of revisions. You can have multiple releases of the same chart with different names and configurations. Releases are tracked as Kubernetes secrets by default in Helm 3.
How do you list and manage Helm releases?
You list releases with Helm list, which shows all releases in the current namespace. The All Namespaces flag shows releases across all namespaces. Helm status shows the current state of a specific release. Helm history displays all revisions of a release, and Helm get values retrieves the values used for a specific revision.
What is the Helm package command?
Helm package creates a version chart archive as a TGZ file from a chart directory. This packaged chart can be shared, uploaded to a chart repository, or pushed to an OCI registry. The version flag overrides the version in chart YAML, and app version sets the application version. Packaging is typically done in CI/CD pipelines.
How do you create a new Helm chart from scratch?
You create a new chart using Helm create followed by the chart name, which generates a directory with the standard chart structure including a sample deployment, service, ingress, and values file. You then customize the templates and values for your application. The generated chart includes best practices like resource limits, probes, and service accounts.
What are named templates in Helm?
Named templates are reusable template snippets, defined using the define action and invoked using the include or template function. They are typically placed in helpers TPL and are useful for generating common elements like labels, selectors, and resource names. The include function is preferred over template because it can be piped to other functions like nindent.
What is the nindent function in Helm?
The nindent function adds a new line followed by a specified number of spaces for indentation. It is commonly used with the include function to properly indent multi-line template output within YAML structures. For example, include chart labels .pipe nindent 4 ensures labels are correctly indented at 4 spaces.
How do you handle environment-specific configurations in Helm?
You can create separate values files for each environment, such as values dev YAML, values staging YAML, and values prod YAML, and pass the appropriate file with the F flag during installation. Helmfile extends this with native environment support. This approach keeps the base chart generic while allowing environment-specific customization.
What is a Helm chart museum?
Chart Museum is an open-source Helm chart repository server that supports multiple storage backends including local file system, Amazon S3, Google Cloud Storage, and Azure Blob Storage. It provides a REST API for uploading and managing charts. While still used, many teams are migrating to OCI registries for chart storage.
How do you sign and verify Helm charts?
Helm supports chart signing using PGP keys through the Helm package sign command, which creates a provenance file alongside the chart archive. Users can verify the chart integrity and author with Helm Verify. This ensures that charts have not been tampered with and come from a trusted source, which is important for supply chain security.
What are Helm post renderers?
Post renderers are external tools that process the rendered Kubernetes manifests after Helm templates have been evaluated, but before they are applied to the cluster. They are specified with the post renderer flag and can be used for tasks like applying customized overlays, injecting sidecars, or enforcing organizational policies on the final manifests.
How does Helm handle resource ordering?
Helm installs Kubernetes resources in a predefined order based on resource type. Namespaces and service accounts are created before other resources, config maps and secrets before deployments that reference them, and so on. This ordering ensures that dependencies are available when resources that need them are created.
What is the lookup function in Helm?
The lookup function queries the Kubernetes API from within a template to retrieve existing resources. It takes API version, kind, namespace, and name as arguments. This is useful for conditionally creating resources based on what already exists in the cluster, though it returns empty during Helm template since no cluster is available.
How do you manage secrets in Helm charts securely?
Best practices for secrets in Helm include using external secret managers like HashiCorp Vault with the Vault Agent Injector, using the external secrets operator to sync secrets from external stores, or using sealed secrets to encrypt secrets that can be safely stored in Git. Avoid storing sensitive values directly in values files committed to version control.
What is Helm repo index?
Helm repo index generates an index YAML file for a chart repository from a directory of packaged charts. The index file contains metadata about all available charts and their versions. When hosting your own chart repository, you run this command to build the index that Helm clients use to discover and download charts.
How do you debug Helm template rendering issues?
You can use Helm template to render charts locally and inspect the output. The debug flag provides additional information about the rendering process. The dry run flag with Helm install simulates an installation and shows the rendered manifests. Adding temporary template comments and using the print function can help trace values through complex templates.
What is the to-YAML function in Helm?
The to-YAML function converts a value to YAML format within a template. It is commonly used to inject structured data from values into templates, such as resource limits, node selectors, or annotations. It is typically combined with indent to ensure proper indentation in the output YAML.
How does Helm handle namespace creation?
Helm 3 can create the target namespace automatically if you pass the Create Namespace flag during installation. Without this flag, the namespace must exist before installation. When a release is uninstalled, Helm does not delete the namespace, as it may contain other resources. Managing namespaces separately is often preferred in production environments.
What are some common Helm best practices?
Best practices include using semantic versioning for charts, defining resource requests and limits, including health checks and readiness probes in templates, documenting all values in values YAML with comments, pinning dependency versions, and using Helm lint and Helm template in CI pipelines. Always use named templates for repeated patterns, and keep charts focused on a single application.
How do you migrate from Helm 2 to Helm 3?
The Helm 2 to 3 plugin facilitates migration by converting release metadata from the Helm 2 format stored as config maps to the Helm 3 format stored as secrets. The process involves installing the plugin, migrating Helm configuration, converting releases one at a time, and then cleaning up Helm 2 data. Testing the migration in a non-production environment first is strongly recommended.
What is the difference between Helm get and Helm show?
Helm get retrieves information about an installed release from the cluster, such as the deployed manifests, computed values, and release notes. Helm show retrieves information about a chart before installation, including the chart YAML, default values, and REIDME. In short, get is for deployed releases and show is for chart packages.
How do you use Helm with Git ops?
In a Git ops workflow, Helm charts and their values are stored in a Git repository, and a Git ops operator like Argo CD or Flux watches for changes. Argo CD has native Helm support and can render charts directly, while Flux uses the Helm release custom resource. Some teams prefer rendering Helm templates to plain manifests and committing the output for full transparency.
What are Helm chart tests?
Helm chart tests are pod definitions in the templates/tests directory, annotated with the Helm sh/hook test annotation. When you run Helm test, these pods are created in the cluster, and their exit codes determine pass or fail. Tests commonly verify that services are reachable, databases are accessible, or IPIs return expected responses after deployment.
How does Helm handle failed installations?
When a Helm installation fails, the release is recorded with a failed status. You can use Helm status to inspect what went wrong. The atomic flag automatically rolls back a failed installation, and the wait flag makes Helm wait for all resources to be ready before marking the release as successful. Failed releases can be cleaned up with Helm uninstall.
What is the atomic flag in Helm?
The atomic flag makes Helm automatically roll back an installation or upgrade if it fails, or if resources do not become ready within the timeout period. It implies the wait flag, which means Helm monitors the deployment until all pods are running. This provides a safety net for production deployments by ensuring either a complete success or a clean rollback.